Cool. Well, thanks, Sam, for having me.
Yeah.
My bio didn't say much online, so I'm going to get into that here in a bit. But my name is Bengtson. I am head of security at a health data tech startup called Nuna Health. We do data analytics on healthcare data. We just recently went public stating that we are doing data analysis on all of Medicare and Medicaid data for the government. So you can see the importance of security there in that we're protecting over 74 million healthcare lives within the nation. Sam asked me to come talk to you guys about a career in, or I guess my career and just careers in general in the computer field. So I thought a clever way for this title would be hacking your way to a successful career, one step at a time. And I thought maybe it'd be interesting to walk through kind of my career and where I've come from, and then tell some stories along the way. But who am I? So I mentioned I do security at Nuna. We're health data analytics. I'm Muscles on Twitter, also at DEF CON. I love cloud security and open source. I've really grown into cloud security, and if I could recommend one field to go into currently, it would be cloud security. There's not enough people that actually know how to secure the cloud effectively. And with such a movement to the cloud from hard metal servers, it's vital important. But I guess some of the exciting news is in 3 weeks, I will be security operations at Netflix. So I've actually taken an opportunity to go work at Netflix and step out of my role of leading security at Nuna to go tackle a bigger challenge of security at scale at Netflix. So what have I done in the past? I've worked for companies like Hewlett-Packard, Raytheon, Cigital, Lockheed Martin, Nuna, and eventually Netflix. So I've been in the career for about 10 years now. So as I go through this career, I'll tell you my thoughts as I was going through here and how I kind of maneuvered my way. But first off, in college, I went to school at Texas A&M. I got my undergrad in computer engineering with a minor in math. I later went on to do a master's in cybersecurity through Southern Methodist University. Recently, I've been thinking about doing a PhD, trying to find time and figure out what my dissertation topic would actually be. Most likely around cloud security of sorts. But I also teach as well, just like Sam. I teach for the University of Texas El Paso. I'm a lecturer there teaching a master's course in secure wireless networks. I've been an advisor for the university for a couple years now. Most recently advised them through their NSA cyber operations accreditation. And heard also that my course was rated one of the top courses by the NSA for the cyber operations schools, which is kind of cool. But back in the day, I started at Hewlett-Packard at their research facility there in College Station. And I basically did a whole lot of this. I analyzed and certified our platforms originally on hard drives and actual CD-ROMs. So manufacturers would send us hard drives and CD-ROMs. We'd certify them against our enterprise blade servers and enterprise just business class servers themselves. I then moved into actually category 1 and 2 certification of the actual processors. So Intel and AMD would send us actual processors to certify against our systems. So we'd be certifying them for virtualization, multi-threading, things like that. So I basically went from putting processors in systems and hard drives to actually managing the teams that did this for Hewlett-Packard. So we were a satellite research facility doing some research in virtualization hard drives, but mainly just certifying them across the fleet. So you couldn't say that your hard drive was compliant with our systems unless it went through one of my teams. So I got my first taste of computers there and actually in the field. But then decided that I wanted to go to Raytheon. And Raytheon did a lot of cool things. Mainly I supported the mission of the soldiers. Whether you support that mission or not, I supported bringing our soldiers home safely. And through that, I was doing embedded software. So out of school, I guess I went to school to learn software, and I wanted to learn hardware as well. I always thought that everything needed to be programmed one day, so I didn't know how to program it, be it a circuit board or a computer. So all the pictures I'll show you here shortly are pictures of systems that I've actually worked on. So this one is called the LRAS, the Long Range Advanced Scout Surveillance System. It is a common system used by the Army Scouts to go out in advance and search for clear passage, search for enemies, targets. It has cool features or core capabilities are far target location. It has GPS. It has 2 antennas on top. You can kind of see them. These two little circular discs on the top. They're actually 2 different GPS receivers, and they're spaced out on the lid like that, such that you can take the differential GPS and actually get a bearing of the system, accurate to a certain degree, such that when you're actually trying to locate someone or a building, you could actually look at the building based on where I am and the direction I'm facing and how far the building is away, calculate the actual target location of the building. With that information, you could radio ahead, say avoid this location. You could do other things, call for fire and all sorts of stuff. So I supported that mission. There I was writing software for some of the embedded processors, as well as supporting formal qualification testing. But all due to just knowing how to write software. From there, I graduated and went into research and development for the company. So you can see this kind of looks similar. This is what's called the enhanced LRAS 3. So we decided to make a 3rd generation version, similar to cellular technologies where you have 1G, 2G, 3G. In the forward-looking infrared field, you have the same. So this was our first advancement in 3rd gen forward-looking infrared. And so this was an internal research and development project that I was on, which was kind of groundbreaking in the defense world. If you think about how software development works in where we are in San Francisco, the tech scene, it's very DevOps friendly. It's continuous integration, continuous deployment. But when you go into the defense world, from inception of design to actually implementation, sometimes takes several years. So I was very lucky to actually have an opportunity to go from an initial concept through actually delivery of a system, and we did so in less than a year, which was kind of amazing. So this system itself is pretty cool in that it actually, this smaller lens on the left is a colored ATV camera. So not only did the soldiers have a new 3rd generation FLIR, they actually had a colored ATV camera to do advanced recon with as well. So not only could they say, you see that truck a mile out, they could say, do you see that red truck a mile out? Which is kind of neat. I mentioned before the 2 antennas on the top. This system actually was upgraded with an IMU, which is an inertial measurement unit. What it actually does is it was sensitive to the fact that it could actually detect based on the Earth's rotation and determine which direction it was actually pointing. So it had multiple accelerometers, gyros, and magnetometers to actually determine which way it was pointing instead of using differential GPS. So in this system, we use the same type of GPS system, but only 1 antenna, and we're able to use gyros and accelerometers to determine which direction we're facing, which is kind of neat. So this picture actually I took in the field. One of the things that I always like to do when I work on a system is try to understand the system as a whole, not just my component of the software that I'm writing, but how my component interfaces with the other components, and then how the system works together. And because of that, I always had the opportunity to actually go out in the field with these systems and teach soldiers how to use them. And if something were to go wrong, I knew enough about the entire system in general that I could troubleshoot it. So that was really, really neat. From there, we were able to integrate things like this. This is called the Boomerang. It is a sniper detection system. So the antennas here are actually microphones. So it can detect the initial shot, the sound of the gun firing, and then detect the velocity of the bullet, the trajectory of the bullet passing through the microphone array, and determine which direction and how far the bullet came from. So with that, and you can see they have 2 antennas here. So with that 2 information and the GPS antennas, it could calculate a rough location of where that shot came from. We were able to do really cool things like network this with one of the previous two systems I mentioned to actually put up cues in the sight to point you to look at the actual enemy combatant or whatever, which was really neat. So I got to play around with a lot of cool things, all through just due to the fact that I was interested in software, I understand systems really well, and I just liked what I was doing. One of the last things I worked at Raytheon was a system called BattleGuard. And if you go to YouTube, there's a really cool video. I like to claim that half of the shots being fired in the video is me. I spent lots of time at the gun range integrating the system. But the system here, the BattleGuard, is this gun here. This sight right here in the middle is what's called the commander's independent viewer. It sits on a Bradley fighting vehicle. Normally in theater, the commander only has a sight. Doesn't have anything to engage with should he need to. There's a main gun on the Bradley of a 20mm cannon. There's some side guns as well, but a commander's job is typically to just view terrain and guide and give orders. What the BattleGuard actually did was we were able to put a gimbal that kind of slid over the CIV and actually were able to bore sight weaponry to the actual CIV, which enabled the commander to actually take action should he feel the need. So it was really important for protection of our men and women, but also just another fun system. But here I got to do things like control theory and actually controlling, when you actually fire the gun, you have to take into counter effect on the gyros of the system to make sure that you continue to keep alignment and you're not just going off. But it was a lot of fun. And once again, another thing, because I was good in software and understood hardware, I was able to get out here and do that. I guess taking a step back, when I was first in high school, I wanted to be a spy. I watched the movie The Recruit, and Colin Farrell was this hacker spy guy, and I was like, that's what I want to do. I applied to the NSA, I didn't get in, and I kind of lost my security touch. Went to school to just do, as I mentioned, software, studied computer engineering, knew I wanted to learn hardware, kind of forgot about security until I got back into Raytheon. And as I was doing these systems, I realized that, hey, we have to actually protect these systems. As we network them together, we want to make sure they can't be tampered. That led me down to the path of reverse engineering and anti-tamper. That's kind of where I first got back into security. And so this is a picture of a board being x-rayed to try to determine underlying traces and hidden components or vias. So the last couple of years at Raytheon, I spent heavily in reverse engineering and anti-tamper, as well as cybersecurity. Raytheon had a program called the Cyber Professional Program, which was basically a 6-month hacker boot camp. They taught us everything from what Sam was showing you, looking at actual opcodes and the binary, to network testing, to fuzzing, to everything. It was really cool in the courses to actually learn how to look for 0 days in common applications.
Did you actually find hardware Trojans in boards?
I did not actually find hardware Trojans in boards.
Yes, it's just making sure they are.
Yeah, so a lot of these were, if you get a board, what typically happens is you'll find countries to decide to actually make things that we make, right? The US is known to be a pretty advanced country, and so we do anti-tamper as a method to not only protect the systems as they operate, but to protect the actual intellectual property that we put into the systems. So anti-tamper, there's no such thing as foolproof anti-tamper. Its goal is to make things too expensive and too timely to actually try to reverse engineer. So with enough money, time, and samples, you can reverse engineer anything. So the goal of anti-tamper was to try to make that harder. So we'd come across boards in training that had coatings on them to try to hide chips. And if you were to remove the coating, they would deface the chips. You'd have special chips that you could get made that didn't have any labeling on them, so you couldn't tell what kind of chip it was. You'd have multi-layer boards, so you'd have traces on the middle layers, and you'd be literally taking x-rays to try to determine where traces are going. Really fun stuff. It's almost like a big puzzle, but trying to look for those JTAG lines and things like that if anyone's familiar with hardware. So that kind of really spiked my interest of getting back into security. That got me into the cyber professional program, which led me to doing a lot of security on the side, bug bounty programs, trying to just find vulnerabilities, setting up hacking labs at my house, which then led me to coming across a company called Cigital. Has anyone heard of Cigital by chance? Cigital is actually the world's largest software security company. When I joined them, it was 250 people, which is kind of crazy. You think of a large company, you think of thousands of employees. But when it comes to security, you find that there's few and far between people that can actually do the job well. So at Cigital, I think you guys had a talk already that mentioned like breaking into buildings physically and stuff. So this, I didn't watch the entire talks from the last presenters, but I believe someone mentioned cloning badges. So this is a picture of a Proxmark III. I own one, they're great. My old apartment only gave me one fob to get in, so I made copies in case I lost one, because it was $250 replacement if you lost it. So I made a copy of the one they gave me, I put it away, and then I could get in with my others.
Isn't the whole point of it that you can't just make a copy?
The whole point of it is, so the interesting thing with Prox, I don't know how much in detail the last presenter went into, but this card here, for example, the ProxCard 2, there's two types of technologies when it comes to RFID. There's the low class and the high class. Low class is 125 kilohertz. It does not support encryption. When it was first created, there was no such thing as security, I guess, or security's never been in the forefront of people's minds, right?
How can you not be thinking about security? You're making a lock.
They thought it was, I guess, safe enough that this technology didn't exist to clone them, so they were secure. But these literally are as simple as reading and writing the same data. The new versions, the high-class versions, operate at 13.56 megahertz, which is a lot harder to clone, but it actually supports encryption.
The lower version, the retail value is about like $6 or $5 or $6 per card, right? Mm-hmm. The high end, are we talking about how much more?
Same.
Really?
Yep. Same cost, and all the readers they sell these days are what they call multi-class, so they can read low and high class. But they're about all the same cost these days. It's just whether or not your systems are equipped to handle them. And most likely your buildings have been installed with the old versions and no one's willing to do the upgrade. So the really interesting thing is when I can move to the next slide, one of the first things I did at Cigital, like one of my main jobs was what's called red teaming. Has everyone heard of red teaming before? So red teaming is basically objective-based penetration testing, or in other words, full scope, no holds bar, pretend to be an attacker that really wants our data. So most of the times in red teaming, physical penetration testing was on the docket, which actually meant that I could go break into buildings, right? I could use the same things on lockpicking that you guys have seen already. I actually built a big version of this. You can buy a parking lot reader online for about $150. It's about a 12 by 12 thing for about $20 in embedded electronics. You can build a board and hook it up to it to actually read the values on it. So what I did was I built a portable version of a parking lot reader, put 8 AA batteries in it. I used to put it in my backpack, and I'd walk around the building, tailgate someone to lunch, sit down next to them, and then I would go to my car, to the Proxmark III, and then write their badge out, and then later on enter the building as if I was that employee. Really, really useful, kind of scary when you think about it, because I don't have to touch you at all. I can just walk by Sam 2 to 3 feet away and copy the card.
Now, in RSA, they give out these special envelope where you can put a car. What is the material that anti-shield?
Yeah, it's just a shielding material of sorts. You can use like foil, is a good good material. Some of them don't work very well. Some do. So use them at will. Even if you have an RFID shield. The way RFID works is it's a passive device, right? They have active RFID that are battery powered, where it's constantly sending a signal. But with RFID, it's a passive device, so when you actually put it to a reader, the reader is emitting energy, and that energy is reflected off the circuit. And then based on the responses, how it's programmed. So that's how RFID works. So with a large enough energy source, you could penetrate your device or your protection shield and potentially still get a response. So not only did I do red teaming at Cigital, but I went to school for software. A lot of the people that actually worked with me at Cigital came from IT jobs or they were network engineers, so they didn't actually write software, so it kind of limited them in scope of what they could actually do. So that's one thing that people ask me, what should I do to get into your field? I tell them, go learn how to code. And not just how to be a script kiddie, but go learn how to actually write software. By knowing how to write software, it opens you up to do things like secure code review. You can actually read and understand other people's code and determine if they're checking the bounds of an array, see if they're trying to overwrite memory, things like that. Not only did I do secure code review, I did malicious code detection. So not looking to see is the code written securely, but are there several pieces of code written such that when pieced together, they perform malicious functions, right? So companies would pay us to look through their huge code bases to try to determine if there's backdoors, if with a certain command it opened up a new process that then allowed you to get into a backdoor, things like that. Nowadays, I use what I learned from back working at Cigital to put in protections to prevent malicious code detection or malicious code from actually being inserted into our code bases. I also did architecture risk analysis. And this could be from a single set of software to the entire system itself. But in architecture risk analysis, you're actually doing a big system type view and looking for threats. You're identifying assets, controls, and threats. So what am I trying to protect? How am I protecting it? And how will I try to be attacked? And then overall, in the end, it's a big report on where you're weak, what you're not doing, what you're assuming. There's things called trust zones, where you assume, a big common trust zone that I found when consulting was they assumed that their internal network was safe. So they would do encryption from the internet to the edge, and then they wouldn't do encryption internally because they assumed it was safe, right? So in a threat model, when you're actually if it in scope is beyond the outer edge, you would find those types of things. I found things where the cross-site request forgery token, is anyone familiar with cross-site request forgery? So a web protection to try to prevent cross-site posting. But the cross-site request forgery token itself was an MD5 of the session token. And if anyone's not aware, MD5 is considered broken many, many years ago. It takes about 15 minutes to brute force an MD5 collision. And in many particular cases, sometimes the session was longer than 15 minutes. So if you gave me a CSRF token that was an MD5 of the session token, I could break that and then know your session and then steal your session. So, it was kind of those kind of things where you took a bigger look at the overall design of the system or design of a protection mechanism and picked them apart in this architectural risk analysis. But overall, determining the risk of the system. And that's what security boils down to is what's the risk and can we accept that risk or not? When I was at Cigital, I consulted across many different industries. I worked in the defense department when I was at Raytheon. I went into Cigital and I worked in mobile banking, the financial industry, calculators, all sorts of different things in industries. And I saw things apparent over and over again. But really, really interesting to branch out from the defense world actually into the private industry. So I did all these sorts of things and more. Network penetration testing, mobile assessments, so actually picking apart Android and iPhone applications. One of the most common things you find there is applications don't actually use certificate pinning, so they don't know if they're talking to the correct server or not. So it's very easy to intercept traffic, determine how an application actually works, reverse engineer the application that way. Even if they're using built-in like code obfuscation tools, you can, with looking at traffic and how the code works, determine what the actual source does.
So, if you could just elaborate a little bit more on the architectural risk analysis, that you basically act as a pen tester from outside as well as inside.
Yeah, so depending on the actual scope of the architectural risk analysis.
Enterprise level application.
Yeah, so for example, a web application, right? You could do an architect, what we shorten the word to ARA. You can do an ARA on just the actual front client-facing piece, right? So the web authentication, how that works, how you handle CSRF protection, cross-site scripting, things like that. And you can leave it at that level. But if you want to include the back-end systems that it talks to, then that opens up the scope of it a little more. And then at that point, you start asking the questions of how does your server communicate to the database? Does it use SSL? Does it use root as the user to actually connect to it? Are there multiple servers involved? Do they all use the same password to connect? Those kind of things would be like you basically are interviewing developers, looking through documentation, reading all that, and then coming back to form a conclusion and give your best assessment. Common things that you find is when talking to different developers in different groups, they have different opinions on how things work. And that's when you start finding the issues in that I implemented this piece, but I thought you were going to use it this way. And you thought I had the protection built in, and then overall there's no protection. Because you thought I was doing it, I thought you were going to do it, and then there's no end-to-end system tests that actually comes together in the end. So the ARAs can be as simple as just looking from the outside in, or going into multiple systems. I did one as large as CDNs all the way to the web app front-end server, to the back end, to the mainframe, to cross systems that queried and dumped data, ETL systems. And then at Nuna, we do this all the time in that we look at our product, and as we design a new data platform, for example, on how we actually receive client data to enrich it, to deliver it, all those systems determine where can an attacker maliciously input stuff, where should we catch things, how are we communicating to systems, what credentials are we using, what permissions, who has access to what. All that comes into play.
So if your client is having a what they call expert, Cisco UCS or unified computing self-contained engineers, is that more secure than various?
Yeah, I'm not familiar with the Cisco device you're talking about, but there's no such thing as a secure device. I guess a secure device is a device that you've turned off, put in the safe, put that safe in another safe, throw the key away, kind of deal. Even in the most secure systems, you can configure them insecurely. Or if you're not protecting the overall password correctly, then your secure systems become insecure. So you can design complex distributed systems very securely that are just as secure or more, if not more secure than a single secure device itself. It all depends on how you want to do it. Oftentimes, even on secure devices, if it's all contained in one system, or if you consider like a container system with Docker containers, they think, oh, all the containers are running on the same system. We don't need do TLS between containers. But what happens if I break out of one container and then I can see all traffic in between other containers? So oftentimes it's insecurities in system design are trusts in the end. I didn't think that this could ever be exploited, so I'm not protecting it this way. But most of it is a cost-risk analysis, and do we want to spend time to implement that? Most of our times at Raytheon when we were discussing anti-tamper with programs was designing security from the beginning was much more cost-effective than having to design security once you've actually implemented something, right? It's a lot harder to revamp a design and put security in if you don't design it from the beginning, right? One of the mottos at Cigital was build security in, and it's truly, making security part of your secure development or your software development lifecycle. Having several touch points and making sure not to forget anything. So after Cigital, an old teacher of mine recruited me to Lockheed Martin. So I actually took a step back and went to the defense world again. There I did a lot of consulting internally to Lockheed, kind of like what I did at Cigital. I did some consulting in the private industry also, but most notably, at the end, I spent 6 months in Japan building the incident response team for the F-35 there in Japan. So that was a lot of fun, getting to build a actual security operations center, working with the Japanese over there, learning cultural differences, but applying knowledge as an attacker on the defensive side. So most of what I was looking for, building alerts and things like that, I was thinking, how would I attack this system? If I got in, how would I normally compromise this? What should I be looking for? What are the indicators of compromise that I should be tuning our monitoring systems for? So if you're not familiar with incident response, the biggest thing to do is monitor, and then tune, because you don't want to be just running down false positives left and right? You want to automate as much as that as possible to scale your team and scale your efforts. But there's never enough logs. You can always use more. From there, I went to Nuna, where I am now. As I mentioned, we're a healthcare data analytics company. So we're trying to tackle one of our nation's biggest problems, which is the healthcare system. Our overall mission is what should the price of healthcare be, and what does quality actually mean within healthcare? So we do that through gathering, learning, and improving on data sets. So we have a huge team of data scientists, and security has been a foundational piece at Nuna. One of the interesting things from when I joined Nuna, the company had already been running for a good year or so with a security team. I came in as security team member number 2 of the second security team, and I've spent the last 18 months cleaning up and rebuilding things. But my main focus at Nuna has been Amazon Web Services. We run entirely in Amazon. And so cloud security, as I mentioned earlier, I love cloud security, and it's truly because of Nuna that I love cloud security. It's a fascinating world when you think about cloud security at scale. And that's part of what's led me to accept an offer at Netflix, is the scale of Netflix and that challenge is very, very exciting. But because of Amazon Web Services, Nuna's a company, and because of my understanding of security, software in general, and just engineering principles, I've been able to succeed at that at Amazon. Spending time both in security, but also reaching outside of security to the engineering population in general. Making sure that they're putting engineering best practices forward, doing continuous integration testing before they're actually deploying things. So we almost took a step back and asked, how do I internet again? When I first got there, there were some really, really bad things going on. I remember pairing, and pairing is working side by side with an engineer. 2 eyes on a piece of code is better than one kind of deal. You learn from each other, a good mentoring, mentee type deal. But I remember asking how they connect to database systems, and could we connect to this database and figure out how it works? And I remember the engineer I was pairing with was logged into our web application, just said, yeah, let me get the connection string, browsed to an endpoint on the web application, and on the screen was returned all the database connections, usernames, passwords, connection strings, which as a security person, I almost had a heart attack. I was like, oh, no, this is horrible. But I'm happy to say we don't do that anymore. We like to do things, very secure. Some of the things that I've put in place at Nuna, which has, at least in my opinion, helped our security. We redid our entire key management system. So we use an open source tool called HashiCorp Vault. That is a centralized key management system of everything that we do. It manages secret passwords, or static secrets, excuse me. I mentioned earlier in the ARA, are several systems using the same passwords for the database, right? Well, with HashiCorp Vault, they have what's called dynamic leases. So each system actually reads a dynamic username and password from Vault for databases. So we can guarantee that no two systems have the same database username and password. We can also, if we determine that a system's been compromised, revoke that password itself and not take down any of the other services. If you've shared a password among multiple systems and you have to revoke that password, you've then taken down those multiple systems. So we get to do a lot of cool things like that. Has anyone ever heard of Ansible or Puppet or Chef? It's a configuration tool, right? So you can easily bring up systems. When I first got there, we were distributing SSH public keys to systems with an Ansible script. That became problematic in that you had to find the person with access to every system in order to get your key on the system that you needed. But also it became an onboarding, offboarding nightmare. When you left the company, we had to make sure your keys were removed from the system. So one of the things we did was actually build a centralized SSH system so that all of our systems, when you try to SSH in, it'll reach out to a central place and say, do you have access? Do you have a key? Should I let you in kind of deal? We put two-factor authentication on all of our SSH sessions. So not only do you have to have the key, but you have to be able to do the two-factor authentication as well. We adopt the DevOps mentality, which in DevOps, it's this continuous deployment, continuous delivery. Blue-green is a common term, red-black, depending on where you are. But it's basically bringing up an entirely new system before tearing down the old system so that you get a continuous, uninterrupted system lifetime, application lifetime. So one of the things that we actually did, and I think to the date, I still have not heard another company do something like us. We use Active Directory as our centralized identity management system. And most companies will, on Patch Tuesday, actually patch their systems. Sometimes patches can fail and then you have to figure out how to roll back. But also if you patch a system and have already compromised your system, you have not removed that compromise. So what we actually do is we spin up a whole new set of AD servers. We join the actual domain, transfer FSMA roles, and then tear down the old servers. So we actually, every time we patch, we bring up an entire new set of servers from a clean, known, good state, and then we tear down the old ones. So it guarantees us not only that we're bringing up a fully patched system, but that it's an uncompromised system as well.
And do you have some kind of script for that?
We do.
Like Puppet or Chef? Is it
Yep.
PowerShell or what?
We use Chef, and it's PowerShell.
Chef does Windows.
It does.
Very nice.
Or at least we figured out how to get it to do Windows. Which is nice, because if you make a change, then the change will go away.
Oh yeah, that's really smart.
But yeah, it runs a bunch of PowerShell for us, basically. But it really makes, from a security standpoint, it makes it really, really nice, because we can set that assurance that our domains come up at the same time. If we ever did connect or detect a domain compromise, so I guess as a life of a red teamer and an offensive engineer, when you compromise a domain controller, there's no true state of uncompromised unless you totally rebuild the system. When you compromise a domain, you can get things like the Kerberos key, which if you have the Kerberos key, you can create any ticket in the Kerberos system that says access to anything. And most companies, when they get a domain compromise, they'll rebuild their servers from a golden image that has the same Kerberos key and they fail to rotate that key. So if you've rebuilt your domain controller off of the same golden image, and now I've extracted your key, I can come right back in once you spent the hours trying to get that back up. So the one thing that scripting everything and automating things have done for us is in an event of a total compromise, we have a known user state in a JSON file secured that says group membership and users. We can rebuild Active Directory with a full password reset and Kerberos key rotation in less than 5 hours, which is pretty. It sounds like a long time, but that's very, 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 very fast, right? If you look at the Sony compromise, it took them weeks to come back from that. So when the cool thing about security and working with like infrastructure engineering and getting in the development or the DevOps kind of mindset is you can start automating these things to make compromise of your systems very, very hard, right? Has everyone heard of advanced persistent threats, APTs? So an advanced persistent threat is a nation state. So a country with a lot of money, with a lot of goals in mind that are very persistent, right? So they come at you with network exploits. Most often they come at you with sending phishing emails, trying to get you to click on a link, attacking you both at work and your personal email accounts, hoping that they can compromise from your personal into your work and vice versa. All in mind of getting the one foothold that they need. They're known to move very, very slow, very methodically, sometimes very fast depending on who you're dealing with. But the key there is they're very patient. They can exploit your system and wait a year before they actually make their move, right? They don't want to be noisy. They don't want to show logs, right? If you move too fast or try things too quickly, it's very easy to detect when in your monitoring systems. But if you move very slowly, it's harder to find that you actually exploited those systems. But when you start doing this blue-green deployment, deploying your systems all the time, you force recompromise of your systems. And hopefully by that point, you've patched, right? So you force the APTs to actually change their tactics and procedures. There's a term called TTPs, techniques, tactics, and procedures. By forcing APTs to get out of their mold and move faster, they're gonna make mistakes, they're gonna set off alarms, and overall you're gonna hopefully, not saying it's foolproof, but be at a better spot. So those are some of the things that we're actually getting to do at Nuna, which is kind of neat. So one of the things I love to say when people are asking me how to actually get into my field, where should I start? I always bring it back to, I give 2 words of advice. Go into software, and if you know how to do software, you can go into security. And knowing how to do software, you're going to be at an advantage to security engineers because you can do more things, as I mentioned earlier. But if you want to get to a spot where you never have to look for a job again, go into security. Because there's such a need in the United States to have good, not only security engineers, but good security engineers. There's not enough of them to fill job positions, right? My last 3 job opportunities, I've been fortunate enough to not even have to search for. The recruiters reached out to me, which is really, really cool. I always think it's a neat thing, not to brag, but a way to just articulate that security is a great field if you're interested in it. But most of all, software is a foundation of security that I like to drive through my teams. Because if you don't understand software, you can lead to designing bad solutions, right? Even as an incident response person, I might not be a software engineer, but I want to build tools to help us. If I don't build my tools securely, I've contributed to the problem that you're trying to solve as a security team in the engineering population. So I often give someone an example like this. This is a Python script or a little snippet that uses the request libraries. So what this does is it actually gets a web request. So it reaches out to GitHub to their timeline JSON file, which should hopefully return a JSON. And then it's looking for the word healthy in the content of the body of that message. And if it's healthy, then it's all is good. So I oftentimes ask people, what's wrong with this? Is there anything wrong? And my next solution here might not be the best, but the biggest thing for me is you're not actually checking that you're getting what you're expecting, right? So you've made a request and you're assuming, as I mentioned earlier, you have a trust zone. So you're assuming it's going to work every time. And so here what I've actually done is check to make sure that the response is a 200 code. And in the web world, a 200 means everything worked well, and I sent you the data that you were wanting. If you're getting things like a 403, that's a permission denied. 500 means something really terrible went wrong. But if I didn't get what I wanted, then I'm going to exit and raise a status flag of 1 telling you I exited for a reason. But oftentimes, even engineers on my team will come across code, and doing code reviews in the past, I try to attack them from a not only security piece or frame of mind, but an engineering frame of mind. And so I often ask the question, what happens if this fails? And so this piece of code doesn't really do it justice either, because I have no retry logic. But at least I'm checking the status code. But I've oftentimes trying to just portray good practices in software engineering in general, predict failure, engineer your code such that it's production ready. Even if you're just using it as something local for you, get in the habit of writing things the right way from the beginning, right? Like Sam, I think Sam at the beginning mentioned that, he's told people about problems in their code and they just refuse to fix it, right?
All the time.
It happens all the time. That's one of the reasons I left consulting, is I got tired of recommending fixes and seeing the same mistakes over and over and over again. I wanted to join a company and build things correctly from the beginning. Right? So now working on a security team at a company, I'm the directly responsible individual to make sure our product is secure. And so I can make sure to put healthy patterns in place, put in the frameworks and things like that. When we want our software engineers to log things properly, we don't teach them how to log things. We build a library that logs things properly for them. Right? If you want to prevent cross-site scripting, the best way to prevent it is create a framework around it. That way when you have a new grad out of college coming to code for you, if they use your framework, you don't have your cross-site scripting issues. So we try to do that from a security standpoint at Nuna. And that's really, my life in consulting led me to that, is as Sam sees in all the different things that he takes a look at, there's always bad things. When I got into mobile assessment, when I was consulting, I used to just pull down apps that I personally used on my phone. I eventually stopped doing that because I stopped using the apps. And so now I just blindly trust that they're doing what they're doing. And I avoid mobile banking apps. But, it's a lot of fun, security world, and just software in general. But, I always recommend people, if you're wanting to get into software security or any of that, learn the foundation first. You don't have to go get a master's in cybersecurity like I did. I learned most of the things that I've done through on-the-job training or just experimentation on the side. The resources are there, especially these days. More and more people are contributing resources openly, that you can do whatever you need. But any questions? Yeah.
So back in what kind of analytic platform are you using
So
for data science, like SQL, R?
Yeah, so for data science we use all sorts of different analytic querying languages. So we use SQL, R. We've done some stuff in Python. Most of our ETL systems and cleaning systems are written custom using Java and other tools.
So I take it you guys do a lot of HIPAA compliance.
Yeah.
So how do you factor security with that compliance? How do you enforce it, both for developer and yeah?
Yeah, that's a good question. So how do we force compliance, or how do we achieve HIPAA compliance during development and production, especially around data and query languages? So the biggest piece for us has been just making sure that we have a good story around controlling access to the actual data, right? So making sure that those who have production access can access production, but those that don't can't access production, right? So when we do development, making sure that we actually have synthetic data sets to develop off of, so that we can say not everyone can see the client data itself. So we segment clients. If you don't have access to a client, you can't see that client's data. So we have strict controls around how you access data, who can see what. If you need access, you have to request access, and then approvals have to be put in place. And then we do reviews every so often to see, do you actually need that data? Does that answer your question? Any other question? Yes?
I thought one of the major issues with the healthcare industry was the mobile devices and the third-party apps. You just started with the company. Have y'all just addressed that yet, or?
So we haven't addressed it. Luckily for our security team, it's not part of our business objective. We're trying to just, through tons and tons of data, make decisions and suggestions on things to try to help companies make the right decisions, and healthcare providers, and contract negotiations on what things should cost. Luckily, we haven't moved into a consumer-facing world where we actually have to deal with those mobile applications. But yes, that is in the healthcare HIPAA regulated industry, and I guess I should mention HIPAA. The electronic form is actually called high tech, and there's lots of issues when it comes to those mobile applications, and especially I mentioned cert penning earlier. Not developing secure communication correctly from the beginning leaves your data at risk of being intercepted. People with Android phones, if they root them, malicious applications can gain access to your data in that healthcare app. So it's not only just from a company developing the app needing to make it secure, but also a consumer being aware of the choices that they make outside of that application can negatively affect the use of that application. So it's I think, a hard problem. I'd be interested in Sam's opinion on it. But applications will be reverse engineered. It's very easy to take a compiled application and come up with class code and actually see how it works. When I was doing research and actually boarding passes for boarding airplanes, TSA pre-check is one flag on your boarding card, right? So flip a bit and you get the TSA pre-check light to go off, right? But they also implemented signing on boarding passes as well. So they're trying to do things right. But I learned the structure of a boarding pass by disassembling an airline's app, right? Because their app generates the boarding passes, so it has to know the structure. So I could have gone and looked for the RFC that's public, but it was easier for me to take the app that was on my phone and just look at it. I found the structure and figured out what the actual boarding pass was. It's pretty interesting. Any other questions?
What about the outsourcing? UCSF is going to outsource to India, or most stuff is outsourced to India. I mean, how does that affect things?
So it affects things, at least. So when we work with other companies, we send them a vendor governance questionnaire. We like to think we have a pretty mature vendor governance program. So we send them a security questionnaire, which asks things about their development practices, how they control code, how they control access to production, things like that. Do they outsource software? And so if you ever answer outsourcing software, it kind of raises a flag for us that we need to investigate processes better. like the software that the outsourced companies deliver, how do you vet that software? How do you check for it to not have malicious code? How do you check that it works with your systems well? I haven't personally seen outsourced software, but I've heard many horror stories in that, yes, it's cheaper, I believe, is the main reason for outsourcing, but it's also makes it less maintainable from what I've heard, in that they have a library of code that they end up just copying and pasting together to get something to work. So you're getting from at least what I've heard, you're getting kind of a hacked together solution and not a well-designed one from the beginning. So I think it depends on how you address your outsourcing needs and whether you're outsourcing the entire solution or just a piece. I could see you effectively outsourcing small chunks and then integrating them in and making the necessary modifications to that. But from a risk profile, it definitely increases risk when you start introducing outsourced code. Because you don't control the developer practices that those developers are doing. Now, if it was your company in a different country, that's a different thing, right? But truly outsourcing to a freelancer or just a company overseas can introduce risk to your application. Question?
Because you were talking about your incident response, you set up black holes in the process when you're building it up from the bottom up, like starting from the beginning and setting up all the systems and stuff. And what do you do with that information that you gather?
What do you mean by black holes?
The black holes, where like you set up a server with an address that's like phoning out of the black hole. It's trying to reach out, trying to get to other systems.
Mm-hmm. You're talking about like a compromised server, or?
Yeah, well, when you go back and you're building the servers up from the very, very beginning and stuff, and making it easy to get information if something does go wrong. Mm-hmm. Like, where do you collect your data from? Oh, yeah.
So, depending on the source, you might send it to different locations, right? So, if you're wanting something to just report health, out just like every second report that all systems are good, everything's reporting correctly, you might send that to one location. We try to send everything through a centralized source in a raw format, log it raw, and then send aggregate data of that elsewhere for analysis. We try to not filter any of the logs from the beginning so that we have all the data if need be. When you start, even in like at the Wall of Sheep, it's a bunch of network stuff that we do. If you do network filter captures, then you're missing a lot of data. And if you then decide that your filter's wrong, you've missed all the data and you can't recorrect it. So we often send all our data to a centralized source that gets archived, and then after a certain lifetime gets further archived. So using Amazon, we use S3 as a common place to dump files. And then, so S3 has lifetime policies. And so after so long, the actual files in S3 will get archived into what's called Glacier, which is a long-term storage solution in Amazon. It's just a cheaper storage solution. But then also you're dependent on resources where you're logging, right? So you have to have redundancy plans and disaster recovery plans. Last week on Tuesday, I think it was, Amazon S3 went down. It caused a lot of issues. Like, I don't know how many services I was like, that's running out of S3? Yeah, just a lot of companies, relying on things like that. So when you have a typo, I think is what it was, wasn't it? So like a typo that took down S3 for a couple hours. It has, it could have vast effects on things. But yeah, we try to send things to audit places that cannot be touched, can be read from but can't be modified, and have the verification checks on them to make sure that we can say, especially in our industry, we have to tell auditors and be able to prove that this file was written and hasn't been touched since. Because as an attacker, that's one thing I'm going to do is go audit go try to cover my tracks and change any audit records and hopefully have something go undetected. You know, be it trying to rewrite a log file or just corrupt the log file, depending on how much I want to give my hand away.
Gosh, I think we better let him get out of here.
What about browser restrictions and how much worry do you have on plugins?
Well, let's do those off. Yeah. I think you better let him go. Thank you. Thanks for
Thank
coming.
you.
You got everyone
Hopefully this
excited.
was useful.
Yeah. Thank you.
Thank you.